I'm really excited for this conversation, to be honest, because this sounds like you're one of the OG builders in, like, you're even using this technology or building on this technology before the industry even existed.
I find it really fascinating, collaborative or intelligence, whereby you have different agents or nodes performing very simple tasks. And then you have this emergent intelligence coming over. Like, for example, ants, they're building their nest and they have very simple instructions and they end up building complex structures and domes and everything. I think robots are going to be big in AI this year, maybe not in crypto yet, but definitely in Web 2. So the way I'm seeing things is that Web 2 is ahead in time of Web 3, because Web 2 was already talking about agents a couple of years ago. We got to a first phase, which is LLMs and chatbots and whatnot. We're now getting to the second phase, which is agents. If you notice, what happens is that the AI is becoming more independent, more autonomous. And I think the trend is going to continue until our interaction with AI changes completely from the way it is now, which would resemble like you giving orders to a soldier. They have to be very specific and low level, and you have to double check on the responses, all the way to the orders you would give to a general, which are very sensitive. So privacy matters a lot, and they're very high level, and you just give them the general, like the limits of a playground, and you say, within this playground, use this budget, use these resources to come up with a solution to this problem. And you just leave it there, and it comes back with that answer.
Do I see it correctly if you mean, like, if we compare it to a general, that the general actually has a bunch of soldiers under him? And
exactly.
Yes, and that general then gives the instructions to the soldiers to go do their things. They bring the information back, and it's actually a swarm of agents.
It's a swarm. Swarms right now are not generals, but they would be like sergeants, maybe, something like that. But the idea is that, yeah, you have like this interface, high level one, super intelligent, and then that's going to delegate subtasks to other agents, which are simpler ones, and it's going to orchestrate their work so that you get back something high quality.
Hello everyone, welcome to a new episode of the LP Roundtable. Today I have Miguel with me, Miguel from Nillion, one of the co-founders of Nillion actually, and Nillion is one of the exciting things that are coming up in 2025. I even seen some tweets about Nillion where people predict that Nillion itself will become a narrative, so I'm super excited to dive deeper into what is Nillion, but like always, we start off with who are the people behind the project, and since Miguel is one of the co-founders, I would love to hear more about Miguel's background and how he got to the point of actually starting Nillion, a project that might become a narrative in 2025. So welcome, Miguel. Welcome to the LP Roundtable. Happy to have you here. How are you doing?
Thank you so much, Rick. I'm really excited to be here. Hi, everyone. It's great to be talking about this topic. I think it's going to be very interesting.
For sure, it's going to be full of alpha, I think, and maybe even a bit technical from my side. When I was diving a bit deeper into your background, I was like, ooh, how am I going to keep this conversation going? You're a mathematician. You have such a wide background in patents, in telecommunication, and all of those things. So maybe my first question is, can you share a bit more about your journey and what brought you to this point, to the forefront of decentralized technologies?
Yeah, it's a long journey that started back in 2000 after finishing my engineering studies. So I did telecom engineering and then a master's degree in telecom engineering. I joined some of the largest IT companies back then, so Siemens and Nokia in Germany. And essentially I was working using engineering knowledge, but also maths to compute how big the links in those networks should be. And I got really, really deep into optical networks. And I've realized that you need a lot of maths to master that. So that's why then I went on to pursuing a PhD degree in mathematics. And so I ended up having this kind of fun intersection between maths and engineering in my background. So that was like the beginning. I was very, very attracted to distributed systems back then. I mean, they were not decentralized, but they were systems combining a lot of nodes. And I find it really fascinating, collaborative or intelligence, whereby you have different agents or nodes performing very simple tasks. And then you have this emergent intelligence coming over. Like, for example, ants, they're building their nest and they have very simple instructions and they end up building complex structures and domes and everything. So that was, I think, one passion that I had when I approached the study of distributed networks, be it optical networks or computer networks or mobile phone networks. It stayed there in the beginning.
Okay, you mentioned maths, but for me, maths is something I learned back in the days in school where 2 plus 2 is 4. I've never
Yeah.
even went too much deeper into maths, but like, how does mathematics get to actually decentralized technologies? Like, what's the link there?
Yeah. So, I mean, you start by modeling these systems where nodes act independently. At that time, I was focused on a part of maths that is about capturing the behavior, really. It's about trying to predict how well or badly that network will perform in terms of throughput and bandwidth and all of those performance parameters. So it was very kind of infrastructure oriented. Now, decentralization is a little bit different and comes later in my career. It's about adding, using cryptography to be able to add guarantees and things like fairness into the mix when it comes to designing a distributed network, so that you're able to remove trust from centralized authorities. Because although the internet may look like it's a decentralized network, it's really not. There's a very clear hierarchical structure where you have certified authorities at the top, like the root is the root of the trust in the network. And so you have a very reduced number of CAs that actually control the whole network and are able to virtually kick out people from the network and things like that. To prevent that from happening, that's when decentralization comes in, and it comes in, in hand with cryptography. So that's kind of the new ingredient that I wasn't using back then. It came later in my career, but that enables this wonderful concept of decentralization become a reality.
Were you working about this decentralization or these solutions even before crypto or this industry was around, or what time frame should I see this?
So, good question. So, there was a little bit of that back then because, for example, I was working with PGP. It's a protocol that, unlike the hierarchical structure of PKI, it's a first attempt, I would say, towards achieving a decentralized network whereby the different nodes rate each other. So it is like a very distributed process. There is no central authority calling the shots, and it's about establishing trust between those nodes using encryption. So that's I think a first attempt. Of course, it predates Bitcoin and all the wonderful work that was done then. But I would say it's like there's no binary point where you can say, oh, this is when I started working on decentralized networks. I already was working on that, which is somehow loosely related. Then in 2013, I got interested in zero knowledge proofs, and that's the vehicle that I used then to actually enter the Web3 and the crypto kind of scene. In 2017, I started collaborating with Andrew Masanto, who is co-founder of Hedera and Reserve, and we were thinking about launching a privacy coin. It ended up not being the right time for that. So because you had already other coins like Monero and Zcash and whatnot. But we kept in contact, and I kept on working on decentralized technologies, multi-party computation, fully homomorphic encryption, until in 2021 is when we kind of decided with other co-founders, with Alex Page and Andrew Yo, and later on with Tristan Leader, we kind of decided to start Nillion as a company, as a decentralized infrastructure company.
Okay. Interesting that you say working on zero knowledge proofs in 2013, while I heard people predict that 2024 would be the year of zero knowledge.
Yes.
So like you were super early in all of these things. That's exciting. I'm really excited for this conversation, to be honest, because this sounds like you're one of the OG builders in, like, you're even using this technology or building on this technology before the industry even existed. But before we dive into Nillion, like you mentioned mathematics and algorithms, and I also read that you filed for a lot of patents, and some of those are still in use in the world of telecommunications. Can you tell us a bit more about that and how you rolled into that?
Yeah. So most of those patents, I think there are like 27 that I did during my PhD. They are revolving around the provisioning or kind of the computation of the capacities for the links in an optical network, a big one like the backbone of the internet. And the challenge there is that that's very imagine you have all the traffic coming from different customers aggregated into these big chunks. So how can you predict how much throughput there will be on those chunks? It's really hard because it really depends on the activities and the aggregated activity from millions of users, literally, across the planet. So, and the interesting thing is that this traffic ended up looking like fractals. Now, fractals is this weird geometry in mathematics that, unlike Euclidean geometry, which is the one we're used to, which is circles and lines and parallels and whatnot, this is the geometry of nature. It's the geometry that would describe like the shape of a leaf or the branches in a tree, like really complex natural phenomena. And the internet, as far as I know, is the only man-made thing that is so complex that you have to use this advanced form of mathematics to actually describe it. So it's really interesting that it has this fractal behavior. And if you zoom in, the traffic that you see in these big chunks across different time scales, it has this self-similarity property, which means that it resembles itself. It's like you're not able to aggregate and smooth out all the burstiness, all the irregularities by zooming out. You still have this high variance, which makes it really hard to dimension these links, to come up with formulas and equations that enable you to come up, to kind of compute how big those chunks should be. And essentially, this is what the patents were about, coming up with these equations, with these algorithms, so that telcos can essentially make better investment of their money when it comes to dimensioning and provisioning hardware, or in this case, optical fiber for the links.
Okay, so this is the second time that you compare something technical with nature. We compare it with ants and now with leaves.
Yeah.
Are there any other places that?
I don't know. I always find it exciting to establish those connections between man-made things and nature, because I think we are getting to the point where the things that we're doing are so complex that are almost indistinguishable from the things that have evolved through time, through eons of time.
And then these transatlantic cables, right? They are being in use right now. Like for everyone who is using the internet, these cables are on the bottom of the oceans. And whenever I want to communicate from right now Bulgaria, for example, to the US, my information goes through these cables. Is that correct?
Yeah, that's absolutely correct. We don't think about them, but they are the backbone of the internet. And without that, we wouldn't be able to connect across continents or even within a large continent like Eurasia. And they're absolutely fundamental. And you can see this as, again, like sort of a tree, like where the leaves are the connections to our, mobile devices and computers. And then as you go up the branching tree, or actually go down to the roots, things get thicker because you get more traffic aggregated, and then you have the big trunks that are the ones that I'm referring to, connecting between large cities across the planet. And they're running on optical fiber because it's the fastest thing that we know of, that the signal travels at 200,000 kilometers per second, roughly, I think 4,000 miles per second. So it's really like the fastest way we have for communicating. And that is part of the core infrastructure of the internet.
And then talking about these cables and this whole infrastructure of the cables doing the internet for us, right? That's like how the internet is being run right now. I'm not sure how Starlink comes in there, like if that's a new solution to these cables or is that still working together. But how does your work come into these cables? Do you literally have a hand in the creation of those cables, or what do the patents do there?
So the patents essentially allow, let's say you're a telco and you have to decide how much fiber to buy. So this is the question that the patents answer, because they allow you to predict what the traffic load would be like in the future, and therefore to decide on how much fiber you want to buy, essentially, and where to place that fiber. So it solves that fundamental questions that big infrastructure companies have to answer when it comes to evolving their networks, their existing infrastructure to meet future demand.
Yeah. Okay. And yeah, like we already said, the whole internet is been built on this, and the internet is growing sort of exponentially, I think. And it's only being more important in everyone's life. Like, just like right now, you are talking through the internet with me. And right now we have pretty good connection, it looks like. So, so that's great. In your view, how critical are these fiber optic cables to maintain the global internet? Because I assume the world is not connected everywhere. Like there is certain routes, right? Is there a way that these can be broken? I just remember, for example, when the war in Russia started, there was this one oil
Oh yeah.
where like, and then suddenly whole Europe got kind of fucked in a sense, like, and then probably economy breaks. But I assume something like that can also happen with those cables, or
Yeah, yeah. And it's happened, and it's going to happen again. Like there's accidents. Number one, sometimes boats, they're fishing and they have these nets that they throw, and they kind of drag everything that they get, and including cables, and they break them eventually sometimes. And then also sometimes the tensions are so strong, if you can imagine all the thickness of that cable and the length, sometimes they just wear off, and they break as well. So there's been a lot of improvement in both detecting those problems. Initially it was just visual detection, but then techniques like optical time domain reflectometer, OTDR, was developed that kind of enables you to automatically detect those things. And then people moved on to real time detection. And then I guess, then they moved on to using AI to actually process all the information that they're capturing in real time from those different links, and being able to detect patterns in the use and misuse of fiber, and their functioning and misfunctioning of that fiber. And I guess the next step is decentralization to some extent, right? I think that's the next iteration. Once you have this real-time monitoring system with AI, the next one would be, let's bring in the users and let's bring in their direct experience, because this is, measuring the status of an optical fiber channel is just part of the equation. On top of that, you have many other protocols and things that can go wrong. So what really matters is the end user experience. So bringing all those data points together through a decentralized network is, I think, the next iteration on all these problems.
I love that point what you make about the decentralization, also the monitoring and the user experience, especially of using the internet. And that also segues a little bit in the point I just slightly wanted to touch on. But at Qualu, a project that I recently joined, they are actually using DeepIn to monitor the networks of internet all around the world. And they use the help of DeepIn, the technology, but also the users, where the users can use an app, but also have a hardware device to test it out. And when I use the app, I literally can scan the internet and I see the lines on the world where these cables run. And I can see, for example, with Canada I have a green line, but with Africa I have a red line. So somewhere in this cable something gets stuck. And I love knowing that you have a background in this, and this is also something I've been working on for the past 2 months now. And I didn't even know when I invited you to join the LP Roundtable. So this this is just super exciting. Do you think that like decentralization in this sense could be a breakthrough for the telecom communications? Because right now it feels like these telcos, they are not really held accountable. In a sense, they probably investing, but they don't really know where they're investing or where they should invest. And I think like the solution that Qualu is building could be groundbreaking in a sense to actually hold those telcos accountable. Do you think that's a necessary good?
Yeah, I completely agree. And not just to hold them accountable, but also to provide them with a feedback loop, right? Because
Yes.
oftentimes they're well intentioned. They just don't have that feedback loop as to how well that service is coming through to the end users. So being able to provide them with those data points in real time across the whole infrastructure, I think that's very valuable information. And it reminds me to one of the patents actually, but it was, I think, back in 2003 or four. So it was before we had things like Google Maps and things like that. It was about using the base stations from mobile operators to be able to measure how fast people were traveling on the roads and whether there were roadblocks or jams in traffic and so on. So that right now is completely evident because we have Google Maps and you can see that in real time. I guess what you're suggesting here, which I think is really interesting, is to do something similar, but at a deeper level, infrastructure level, so that you get this map in real time of where the red lines are, where you have jams and problems with traffic, and all that reported by end users. I think that's completely the next step that has
Yes.
to be taken. Absolutely.
That's exactly what we're working towards, combining the fixed internet but also the mobile internet, and people being able to check in places, because yes, a hotel can say we have great internet, but then you arrive there and suddenly you cannot even have a call with a
Yes.
colleague, for example.
Yes.
And that's what we're working towards. We want to work towards a Qualu certified label where people can filter on good internet. Do you think that like Nillion's computation models in a way could help in this monitoring or optimization? I'm just trying to make a link here.
I'm not sure. I think so. If you think about the OZ model, I think that's a very interesting model. It essentially divides the problem of sending information to users in multiple layers, so that you have the bottom layers, which have to do with solving the problem of sending information across a physical link, and then across a logical link, and then through a network, and then using TCP on top of that to provide guarantees of delivery, and then adding session information so that you have HTTPS or HTTP, and then all the way up to the application layer, which is where the applications reside, where the user data is. So I think Nillion is kind of, you can picture it more in the application layers, because we're solving the problem of how can we build infrastructure that is decentralized, so you don't have to make any trust assumptions, and you don't have to trust any centralized provider, but still is able to handle all those personal data, all that sensitive information that is required for building applications. Right now, I think we have lost that important element when going from Web 2 to Web 3. So Web 2 was able to some extent to protect your information, at least from third parties. It's true that you couldn't protect it from the service providers, but at least you can protect it from third parties. And when going from Web 2 to Web 3 and injecting the decentralization element, we kind of went over to public ledgers where everything is public. And so you've lost that privacy. And I think, and we think that that's completely limiting the way in which Web3 is developing itself. And it's kind of putting constraints and preventing it from reaching markets and solutions and developing solutions that require privacy, just the way Web2 works. And so that's the reason why we developed Nillion. And I think that's the right way of looking Nillion, is thinking about, yes, it's infrastructure, but it's kind of solving that application layer problem, which has to do with privacy and decentralization.
I love that, focusing on the application layer and as well as privacy, especially in the times that AI is growing so
Oh, yeah.
fast and everybody's building AI tools and AI things, right?
Yes,
And that, I think there the data got to be protected in a way and also be checked, right?
absolutely.
Maybe just run back in time a little bit before diving into Nillion and the application layer and what problems we're trying to solve. I want to understand how Nillion got to be Nillion. How did you, like, is it you who came up with this new concept, or how did Nillion became Nillion?
So yeah, essentially it all, I guess, started by watching the space. Like you said before, ZKP was there from 2013, and now it's going to be the year of ZKP. Actually, these so-called privacy enhancing technologies date back to the 80s. So they've been around for a while, but they've suffered from a number of problems. The first stage of development, I think the first 20 years, was mostly around whether it's possible or not. You know, mathematicians love to, before doing something, they love to prove that it's possible. And so it was all about really theoretical work, proving that, oh, actually, you can perform computations on encrypted data without decrypting it, without revealing it, which is not a trivial question. So I think it kind of makes sense to answer that before, but no clue as to how to do that, essentially. Then the second period was more centered around protocols, by which I mean solutions to actually do that. So it was good, but it was still very academic. So it was still very theoretical and not professional, in the sense that the compilers and the different tooling that was being created was not done by engineers. So I guess sometime early to 2020, I kind of realized that no, we were about to switch to a third phase, whereby those technologies are already production ready, and it's all about bringing them to production and bringing in engineers, or so-called engineer cryptographers, and implementing them. In parallel, I had been working with in a number of some of those technologies, so multi-party computation mostly, but also zero knowledge proofs. So I knew from the inside out that that was indeed the case. I think that was like maybe the triggering factor, that was triggering element. But undoubtedly, like, I'm a tech person, I don't know much about markets and business opportunities. So without the help of the other co-founders who do have that experience, I mentioned before Andrew Masanto, he's been co-founder of I think 3 unicorns so far. It wouldn't have been possible for me to kind of finish the picture. So wrap those capabilities around something tangible and something concrete in Web3. So that was the summer of 2021. I remember it very, very correctly, where we were discussing about what this technology could unlock. And we were really excited. We were just getting more and more excited by the minute, coming up with all sorts of use cases and applications, until we landed on the concept of creating a new type of Web3 infrastructure that complements blockchains, because it's able to work with private information, with sensitive information, but it's still decentralized. And that is the essence of what Nillion is.
Okay, yeah, I totally understand what you're saying, that you're the tech guy, and that it's sometimes hard to grasp whatever is going on in this industry, because this industry is sort of driven by narrative, and people gotta understand what's the narrative. And the easier it is to explain the narrative, the easier it is for people to understand. And then, like, I think Nillion did a great job from all perspectives. Like, you guys have been very present. I remember being on a panel with Tristan at DEF CON, for example, and he didn't need much time to explain Nillion to me, and I understand it. I'm like, oh wow, it's not a blockchain for AI, it's actually a second layer that can be plugged into any blockchain for
Exactly.
doing these computations, right?
Exactly.
In a privacy way, like a privacy enhanced way. I've heard you say FHE before, heard you say ZK. When I was at DEF CON a few months ago, I felt like FHE is going to be the next thing. Like everyone's talking about FHE, but I haven't really seen that come to fruition. What's your thoughts on all these privacy technologies, and which ones is Nillion using, and what is the best in your opinion?
That's a great question. The short answer is all of them, because the way we see them is that there's no silver bullet. There's no single PET or privacy enhancing technology that will rule over the other ones, will elbow them out and become the only one right there. Why? Because they're different, sometimes functionally speaking. So for example, the things that you get when using ZKP are different than the things that you get when using MPC or FHE. So functionally speaking, they're different. But even when the functionality is the same, for example, MPC and FHE, you have different points in the trade-off space. So these are very complex technologies, and you cannot simplify and say, oh, it's going to be FHE or it's going to be MPC. It depends really on your use case and application. For some use cases, FHE is better. For some others, MPC is better. For example, with AI, where you want to be running inference of large language models, the MPC models are ahead in the curve from compared to FHE models. But for example, for private EVMs, well, FHE is kind of ahead in the curve there. So it really depends on the use cases. That's why what we're building is what we call an orchestration layer, which you can think of in terms of an orchestra. So you have different instruments, each one is good at some things, and you have this maestro, which is the orchestration layer, which all it does is interconnect them and kind of make them play together in harmony. So what we provide to our developers is the ensemble, is the superset of all of those privacy enhancing technologies, in a way, hopefully, if we do the job correctly, in a way that doesn't require them to actually know the nuances and cryptographic details of those PETs, but they just can use them off the shelf to solve different problems like AI or data analytics or you name it. So that's kind of I think it's very important, because when I mentioned the story of the different PETs, they were developed almost in silos. There was the ZKP community, the MPC community, the FHE community. What we're trying to do is to break those silos and actually connect them all together. That's already happening also in some competitor platforms, in the sense that maybe they focus on FHE, but they're using a little bit of ZKP and a little bit of MPC there. But all of them kind of tend to favor one particular flavor. We're not. We're kind of saying all of them are good. Let's bring them all at the same level so they're equally first-class citizens. Let's try to orchestrate them and open up the design space for developers so that they they have a wider design space because they are not just focusing on one particular PT.
Yeah. And who are the developers that you're trying to attract or that you want to see use Nillion? Are those blockchain developers, for example, someone building an application on Solana, or are these more privacy solution builders who build a solution for those builders? Like, who is the type of developers that you see using Nillion?
We're seeing two types of developers. One is the Web3 developer, like the one you mentioned, Solana developer, Aptos, Near developer, any blockchain. They want to be using sometimes they want to be computing on private data or storing private data on a decentralized infrastructure, but they want to use that from the blockchain infrastructure. So they want us to capture events from the blockchain, do some processing, and be able to send a signed transaction back into the smart contract. Essentially, that's one flow. And so it is about extending the existing design space in Web3 to make it more customer oriented, more consumer oriented, because consumers tend to have personal information that is sensitive and they want to put it on a blockchain. So this is about creating a version of DeFi that is more consumer oriented. For example, using uncollateralized lending. So usually the existing solutions, they're all about collateralized lending, but here you want to provide a credit rating score, but that credit rating score depends on sensitive information that sits outside from Equifax or from some services that you consume in Web2. So it's all about using private information. So that's just one example in DeFi, but it kind of touches on all the different verticals. The other type of developer is very interesting and very encouraging because we're seeing Web2 developers for the first time being able to develop decentralized applications. Before, it wasn't the case because they had this same problem. They wouldn't, in Web2, you're used to encrypting stuff and manipulating sensitive information, but the minute they wanted to use decentralized infrastructure, they would stumble upon the problem of not being able to do so. So now for the first time, they can use decentralized infrastructure with private information. And it's really funny to, well, not funny, but it's interesting to see the differences between the mindsets of those two different types of developers, because the Web3 developers are more like backend, like strong on protocols and cryptography, and the Web2 are more like UX, really focused around usability and focused around product market fit and bringing in money and making revenue first. So both are kind of complementary. And I hope that at some point we will cease to speak about two different types of developer and we'll actually have just one class of developers which take into account all of those details which are important. But yeah, it's been really fun and interesting to work with these two types of developers.
It's funny that you mentioned these two types of developers, and indeed, I see this in my experience as well. There is some that take privacy and security super serious, and then there's the other ones that are like, yeah, user doesn't care about privacy, user doesn't care about security, as long as it's user friendly, that's what's gonna bring in the users. And personally, me as a marketeer, I'm in the second part. Like I'm also like, let's
Yeah.
focus on user experience first. And once we have product market fit and once we have the users, like, okay, then we can think about decentralization. But I think you're gonna make your life really hard if you build decentralized first and then gonna
Yes.
try to get the users.
Just for the sake of being decentralized and private. We're completely aligned with that. In fact, our mission is to reduce the gap that now exists between usability and privacy, or performance and privacy. So right now it is a choice, because at least people perceive it as a choice, because companies in Web2 have made us believe that if you are in favor of technological progress, you have to give up on your privacy and you have to use all these technologies that get more and more of your personal data. But actually, with privacy enhancing technologies, that is not the case. It doesn't have to be. So our mission is about making that known in the developer sphere, and also bridging that gap between performance and usability and performance and privacy, so that it ceases to be a decision that developers make consciously, and it's just part of the stack that they use by default.
Yeah. And you mentioned Nillion focuses on the application layer, and that you, in the early days of coming up with the idea of Nillion, there was a bunch of use cases that you explored. Can you give some examples of how you see this technology in use, like some real world examples that you think will be built or are being built?
Yeah, so one famous use case for this technology is custody. So the problem is, where do you keep your private keys? Do you give it somewhere else? Do you store it yourself? It's a nuance and a problem. Ideally, you would have a decentralized infrastructure that is able to store that. You can operate that key, but without actually reconstructing it. And that is exactly what Nillion does and other MPC companies do. It's really interesting because you're breaking the private key into pieces. You give one piece to each node, and you can still have the network sign transactions on your behalf without reconstructing that private key. So that's super cool. Another interesting area is games, because you have the need sometimes to guarantee fairness and correctness for the generation of the randomness, particularly when there's money involved. But that randomness needs to be private. You cannot have it public, because then people would essentially, if it's a poker game, they would know how the cards have been shuffled and things like that. So you want to keep it private, but on decentralized infrastructure, so that you have the guarantees that no one has tampered with that logic and that you have a fair game. In DAO, you have private voting. In DeFi, I mentioned before lending as an interesting use case, but also encrypted order books could be, or actually we have people building that on top of us. So that's also an interesting application. Or private trading policies, where you have a bot that is trading, but you want to prevent front running. So you want to keep those policies private. And in kind of the Web2 part of things, you have things like data analytics, which is very interesting. Now you have a place to put your personal data and have others run computations on it and get insights from it, and you get paid if you want to. Or you're in the center of the control around that data, as opposed to what happens now with Web2, which is that companies do that behind your back. So here you're put in the center, you give consent whenever you want to, and you get rewarded for that. And you have people building things that capture health information from your wearables, all your sleep behavior, heart rate, noise, and allow people or companies to run computations and find things out like, oh, is this thing correlating with that thing? So for example, is noise correlating with a worse quality, of sleep, of REM sleep, things like that. So all very interesting, particularly because you can compute without revealing that information. And another interesting coming from Web2 is use cases around collaboration, whereby you have different companies collaborating together. For example, banks collaborating to detect fraud and help you, be protected against social engineering and other attacks. Or the same applies in a supply chain. You have companies, they have to work together, but they don't want to share information, but they need to optimize their processes. So if they can use this technology, they'll be able to do so. There's ton of applications, as I said, that are really interesting. Some of them are continuations of existing trends like DeFi, DeSci, and Deepin, and so on. But others are completely new things, like this collaboration thing that I mentioned, which makes them also very exciting.
Yeah, that sounds exciting indeed, and sounds like it open up use case, like totally new use cases as well. Like in the order book, what you said, that sounds something totally new to me.
Yeah.
At
Yeah.
least the past few weeks or months, there has been talks about quantum making some breakthroughs as well. Does Nillion keep that in mind as well? Like if quantum gets more to a point where it actually is like at a point that it can be used in the masses, like is Nillion quantum proof in a sense?
Yeah. So that's a great question. Quantum is not a matter of if, but rather when, right? And for example, it's been, well, there's like two opinions. Some people say that we need 200 million, or was it 200,000 qubits to break RSA. Some others say it's going to be like 3,000. We're now in hundreds, so there's still time. But anyway, you have to design for that future, because it's going to happen. To answer your question, yes, Nillion is quantum safe and quantum resistant when we can. What that means is that sometimes we use protocols, for example, the signature protocol I was talking about. Though that's a protocol that is used by blockchains, which are not quantum safe, like Bitcoin, Ethereum, and so on. And unfortunately, we have to use that protocol if we want to send over transactions to them. So those are the only cases where we kind of give up on quantum resistant property. But otherwise, when we have a blank space and we can define the solution from scratch, we always lean on privacy enhancing technologies that are quantum safe, because that's a real problem. It's coming. It's going to be there. There's no question about that.
Okay, cool. So tell me if I'm wrong with this thought process, but if anyone builds a tool and they're using Nillion for the privacy in a sense, then that tool is quantum resistant.
Yeah, exactly. So for example, you want to use, we have three main products. One is NilDB, which is like a distributed or decentralized database. One is NilVM, which is a general purpose compute. The other one is Nil AI, which is for AI. Those three are quantum safe. The only thing that is not quantum safe is when you want to interact with blockchains, because that requires signatures, and the signature protocol that the blockchains use, not us, but the blockchains, is unfortunately ECDSA, which is not quantum safe. Whenever they change it, of course, we will change it as well. But yeah, those are dependencies that we have with blockchains, which primarily are not quantum safe. And it's a major concern, I think, in the space.
Okay, yeah, I think so too. Like some people, when there's an article about it, you see Bitcoin drop. I don't know if there's a correlation, but it's like some people get scared when they hear it's quantum, and the market is like an emotional roller coaster, right?
Yes.
We touched upon AI, and that's how I originally thought what Nillion was. That it was like another layer where the compute could happen for the AI, because AI needs a lot of compute. But talking with you now, I hear there's a lot more that Nillion actually is. And then you just mentioned the three pillars. I would love to hear your thoughts on AI itself, because the past few months, AI has been the hype, the narrative. Where do you think AI is right now, and where do you think AI might go?
Yeah. So AI is not a regular technology. I always see it as a breakthrough, and that means that it's going to impact all different markets and industries. So we need to pay special attention to it. That's why we have this. The third pillar is AI, essentially. Although we have the general purpose compute pillar as well. It's so important, and it's so important for privacy. So we talk about three levels of data. Level one is everything that you're comfortable with being in the public, like the things you publish, the blogs, the podcasts you record, all of those things. Level two is the things that Web2 companies have, which we're seem to be happy with. So giving them over, like cookies and fingerprints in browsers, browser history, and application specific data. But level three is this new category that I think emerged with AI. That is the deepest secrets that you have. If AI wants to be really intelligent and helpful for us, it will have to learn everything about our lives from the inside out. It will have to learn the things we really think about people, the lies we've told, how smart we really are versus how smart we think we are, which might not be the same. The mails and the messages and even the voice conversations we have at home, because they will be listening to that. All our medical history, financial history. This is clearly something that if it ended up being centralized, it would give that company so much power over us, because essentially they would know all our blind spots and cognitive biases. They would be able to manipulate us in ways that we wouldn't be able to detect. So this is like a new level of private data. This is certainly something that we don't want to share with any centralized entity or with anyone in particular. So that's why AI calls for privacy like Web2 technology hasn't done until now. So the second part of the question is where AI is. We got to a first phase, which is LLMs and chatbots and whatnot. We're now getting to the second phase, which is agents. If you notice, what happens is that the AI is becoming more independent, more autonomous. And I think the trend is going to continue until our interaction with AI changes completely from the way it is now, which would resemble like you giving orders to a soldier. To They have to be very specific and low level, and you have to double check on the responses, all the way to the orders you would give to a general, which are very sensitive. So privacy matters a lot, and they're very high level, and you just give them the general, like the limits of a playground, and you say, within this playground, use this budget, use these resources to come up with a solution to this problem, and you just leave it there and it comes back with that answer. So I think with agents we've started along that path of more autonomy for AI, more intelligence, but also more dangerous, because it's going to become intelligent by consuming more sensitive information. So the bots or the agents that we see on Twitter, on crypto, are just a very, very early first iteration on that has nothing to do with private information. But make no mistake, agents will become data sensitive. They will learn, they will give you advice on your finances, on your tax, on your health. So they will have on your relationships. So they will have to know everything about you. And hence the importance of privacy, and hence the reason for that becoming a third leg in Nillion, not just a regular tech. It is something very, very important. I think we're at an inflection point in history. And the decisions that we make now around privacy and security and safety in AI are going to be super important going forward.
I like that comparison you make. Like right now, AI and agents are a bunch of soldiers, and it might go towards more a general view. Do I see it correctly if you mean like if we compare it to a general, that the general actually has a bunch of soldiers under him, and
Exactly.
that, yes, and that general then gives the instructions to the soldiers to go do their things. They bring the information back, and it's actually a swarm of
It's a
agents doing.
swarm. Yeah.
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 Okay.
Exactly. That's a very way of describing a swarm, right? You're in, maybe swarms right now are not generals, but they would be like sergeants, maybe something like that. But the idea is that, yeah, you have like this interface, high level one, super intelligent, and then that's going to delegate subtasks to other agents, which are simpler ones, and it's going to orchestrate their work so that you get back something high quality. Yeah, absolutely.
We've seen evolution from like large language models, which kind of broke through in 2023 with ChatGPT coming up, to now these AI agents being super hot for the past 2 months. But like you say, they're not much more than chatbots or research bots or saying something funny about things. But I've also started seeing speculation about, like, you went from general AI to AI agents to physical AI. That's like the next thing that's been popping up, and that may be something also in the deep in sector, like physical AI and deep in together might be even a next level. Do you have any opinions on physical AI? Because I couldn't really think of a use case where what that is. Like for me, that's too early. I feel like I cannot see how physical AI will work.
I think robots are going to be big in AI this year. Maybe not in crypto yet, but definitely in Web 2. So the way I'm seeing things is that Web 2 is ahead in time of Web 3, because Web 2 was already talking about agents a couple of years ago. And now they're resonating within Web 3 with swarms and whatnot. So I think Web 2 is going to start talking about robots. It's already doing that. And again, I think that that's going to require a new breakthrough, because one thing that LLMs cannot do right now is handle episodes. So whenever you're a robot, you're continuously experiencing inputs and receiving inputs from the environment. So you need a way to categorize those into episodes that have a beginning, an ending, and an intent. Like, okay, my boss had a conversation with his partner, whatever, something like that, or my boss went shopping for that or something, or cooked. Those episodes, that ability to break down that continuous inflow of information into episodes is something that LLMs cannot do right now. They need an episodic memory, which is something that they don't have right now. And again, there's concerns around privacy, because those episodes are a way for the robot, which is around your house, to categorize the things that you do. And if fallen in the wrong hands, it's a machine for spying what you do, right? Because it's not just capturing video, it's actually ascribing or kind of giving intent to that video, and it's kind of, making processing that video at a higher level than just a camera would do. So again, it's a reason for privacy enhancing technologies to be part of the equation. But it's something that I don't think we have solved yet in AI and in LLMs, and it's something that requires, I think, another breakthrough that we haven't seen yet. We might be seeing AG, like general intelligence, but more like the flavor that we've seen so far, which is in a virtualized environment, just chatting and interacting. But the ability to relate that to the physical environment, to interpret actions, like I'm taking a glass of water, I'm drinking, working on the computer, all these things, they require a different type of processing that happens now in the human brain. Also, the ability, by the way, to learn instead of just train and then run inference, but the ability to continuously learn from those inputs, which is something that the brain has and LLMs don't have. All of those, I think, are breakthroughs that need to take place. But that doesn't, that doesn't mean that us from the privacy standpoint shouldn't be working on those already, which we are, by the way, in Nillion. So we are already thinking forward in terms of what that episodic memory would look like and how to protect the user's privacy, because we cannot wait until the technology is ready for us to come up with a solution. We have to kind of be ahead of that event.
Yeah, my next question would actually be, what are the biggest security or governance challenges that we need to address to get to a decentralized AI solution for these upcoming things? But I think you kind of touched upon this already. Maybe we can still go a bit deeper into that question, because these examples that you gave, for example, with the physical AI and the robots, and then if someone could get in there, like that could get very dangerous if somebody actually gets to that data. How could that be tackled? Because right now it's not the Web3 companies that are developing these robots, right?
Yeah, that is another reason for concern, because Web2 companies have a track record of being prone to hacks. I mean, even the best ones have had either faults or failures, or hacked, or have been hacked directly. And the reason is because there's this centralized authority, which is the single door through which hackers and attackers can get to the data, or gain control over their system, compared to a decentralized system, which is much more fault tolerant and also resistant to attacks. So it is another reason to use decentralized AI instead of just AI for those solutions. Because, as you said, imagine, like, someone gains control over a robot that is operating in your home. It could do a lot of damage, but just listening to you, or even doing physical things or physical damage, that's definitely a big concern. And then that has to do with, I like to think in terms of the era that we're living. We kind of went over globalization. That's over. That was last century thing. This century is about automation. So the drive for automation is AI, but you have to think about the infrastructure on top of which you want to be running those sensitive AI processes. And that has to be, I think, decentralized infrastructure with privacy guarantees, for the reasons that we've covered. But going back again to the AI layer, to the drive, there is also concerns, obviously, about safety and explainability. AI is like a black box, and it's very hard to prove that that black box is going to behave within certain rules and controls. So I think there needs to be more progress being made on that front, so that when you put someone, we saw that with Tesla driving cars, self-driving things, but also we will see that with robots, you need to have guarantees that that's going to behave in an expected way. So some people are working not just on operating systems, but systems being able to detect when they're facing conditions that were not present in their training, so that they raise a flag and say, I'm operating outside of my comfort zone. So I stop functioning, and I do something like stop or reach out to a human. That's very important, because if they start functioning outside of their comfort zone, the zone that they were trained for, you could find problems. It is a very complex topic,
Yeah.
but I think very, very important.
Yeah, I think that's definitely something that the whole world kind of got to improve on. The like looking at the direction that we're going, and I've heard some of the more brighter minds that I've been listening or talking to talk about sort of combining DAOs and AI in a sense, where like the DAO, it's not just a Web2 company, but it's more like a DAO that decides on what direction a model takes, or that trains the model, or even the AI, sort of like an AI DAO. I think that's a potential direction for decentralized AI and these decentralized AI applications and models.
That's very cool. It's a very cool avenue, because one problem that DAOs have is that if it's driven just by humans, there will be limitations to the number of decisions that they can make, and the depth of those decisions. So you find problems around that. So thinking about what we mentioned before about the general delegating over to lower rank officials and then soldiers, it could work like that in a DAO, right? So that the general level decision making is done by humans, and then lower levels are kind of automated by AI processes. Because otherwise, I don't see like all the aspects of a decentralized company being operated by humans in an efficient way. We would have too much time being spent on decision making for things that maybe can be automated. So I think that collaboration, that integration of AI and DAOs is certainly very interesting.
It's something to look forward to. I would love to see someone create this and then see how it goes. I would definitely buy. And I think there's some of those tokens like AI16Z that's taking this approach in a sense.
Yes.
It's just super early. We're coming close to the hour. So I want to get to the closing reflections in a sense. I want to ask you, since you've been innovating for the past 10, 20 years into industries that were not known and now suddenly are known, right? The whole world is talking about cryptography, and you were working about this on this a long time ago. Like, what advice would you give to innovators who want to work and contribute to like these decentralized systems, decentralized technologies, and whatever you think is coming?
Yeah, I think let's take it in two steps. Step one, if you want to work in decentralized technologies, I think it's very interesting to learn about cryptography. I find that the people who meet those requirements and are able to work with tech and cryptography are very valued, they're highly paid, and they're very necessary and very, very much needed. That's a very interesting skill or kind of skill set to develop for your career. And it's hard because it combines things like mathematics and coding, which are different languages but not the same language, right? So there's kind of a gap, but that gap is being bridged right now by, as I said before, by technology. So maybe you can focus maybe more on the, if you're stronger on the coding side, maybe leaning more towards that, but you're still using libraries that are cryptographic libraries, so learning about things like multi-party computation and FHE libraries. If you're more on the math side, then don't stay just on the theory, but try and get into the library part of things, because that will give you that dimension of being able to work on products and being able to be useful for a company. So that's the first step. The second step is if you're able to add AI, which is so trendy, but for a reason, because it's, lots of things are going on there. Then suddenly you have the unicorn skill set, because you have tech, you have crypto, and you have AI. And those three things, I believe, are going to decide or rule the next generation of technology that is going to come from the companies. Even though some Web2 companies might be seemingly ignoring the crypto side of things, cryptography and privacy, I think they will come to terms with that, and that they will have to acknowledge the fact that privacy is indeed very important, and they will have to start using those technologies as well. And definitely from the crypto side, that's a given. I mean, crypto is built on cryptography. Maybe that's where the names comes from. But yeah, I think that's a very cool combination to have. So that would be my recommendation.
I love that recommendation. You heard it here, not first probably, but you heard it here again. If you want to make it, get into AI and crypto. Start building. And looking forward, Miguel, what excites you? What excites you most about what's coming up in this space? Decentralized technologies, AI, crypto.
Yeah, so I'm really excited about agents, the way they are evolving. So you have something like vertical agents now that are covering all the different steps from in a production line or in a supply chain. So from the gathering of the core information to the delivery of a product to end users. That's really interesting. That's agents. I mean, I like them as a design pattern, and you have different design patterns related to that. So you have tool use, which is also very interesting. So agents starting to make use of tools, internet tools, financial tools, and things like that. You have planning, so agents being able to divide a complex task into subtasks. You have reflection, agents being able to reflect on their own outputs and refine them. And you have these agent collaboration, which are the swarms. So each one takes a different role and they collaborate and things emerge. You remember how we started this conversation talking about emerging intelligence from simpler things? That's something I think is very interesting and cool. And robots, we mentioned robots before, so I think we don't need to get into more detail there. Otherwise, I think privacy, it's becoming very strong, very Web3, because it's part of decentralization. I've always thought that decentralization is about removing trust from third parties. So what do you trust them with? You trust them with their ability to provide you with a service. So they can censor you out, they can change the integrity of the service. All those are the problems that Web3 initially solved for with the ledgers. But what else do you give them? Do you give them your data? And that's a form of control over you as well. because they can know about you, they can sell that data behind your back, they can influence you. That's privacy. It's a part of that effort towards minimizing trust, the trust that you place in others. So as such, it's part of decentralization, of the decentralization ethos. So I think the industry is now recognizing that, and that's the reason why privacy is becoming mainstream and is becoming such a strong narrative. And I think is the other important thing going forward that we're going to see more of.
I love that, and I think one of the other exciting things that are coming up is the launch of Nillion, right? which
But
is
yeah,
which will be a critical piece of the decentralized AI puzzle. I think, in my opinion, that's how I see it.
yeah,
If we really were like, you'll never get a full AI on chain. That's not really gonna work because on chain has limits. But
yes,
then this could be the critical piece necessary to get to that decentralized AI. I think that's what I'm excited about, to be honest. Um,
yes.
you want to add something there? Because otherwise, I want to ask you about when is Nillion actually going to launch?
That's a great question. So very soon, I cannot give you a date, but it's imminent. And there's going to be two steps. One is going to mainnet, and the other one is launching the token. And it's all going to happen like very, very soon. So that is the most exciting thing for us. We've been building for 3 years now. Initially, the two first years were heads down, building on the tech because we couldn't take off the shelf components from other technologies because we were building something that has never been done before. The last year has been about community and growing ecosystem, which is amazing. The point to which we've gotten and the job done by the marketing guys in coining this term of blind computation as an easy way to explain something that is very complex. So that's kudos for them. But it all comes now to this point where we finally are gonna launch mainnet and then the token. So you can imagine how excited we are about that.
Yeah, it's super exciting, to be honest. Especially like now after this conversation, I'm more convinced about how necessary this is. I think also I grew a few IQ points just in this conversation. So thank you very much for that, Miguel. If
Thank you,
people
Rick.
want to learn more about you or follow you as well as Nillion, where should they go?
Oh, yeah. The best place is our website, so nillion.com. On the top right, you find all the media stuff. You have, if you're interested in news, you go to X. If you're interested in, you want to participate a little bit more, then you can join our Telegram group. If you want to develop, then Discord. And then it's also interesting to go to docs.nillion.com for documentation and masquerade.nillion.com for demos and kind of ideas of what you can do and build with our technology if you were looking for inspiration.
I'll add all of those as well in the show notes on YouTube and Spotify. So whoever is listening to this, you can click on the links. You don't have to go and look for it. I'll make sure those are included. Miguel, thank you very much for all the knowledge you've been sharing here. I really loved this conversation. I was a bit scared at the beginning, knowing how technical. I was thinking about like this is gonna be technical, a mathematician. What's this gonna be? But I think you shared a lot of alpha, a lot of insights, and you kept it really in a sense that I think everyone will understand the value of what you have been building, what you are building, and also a bit like a visionary's vision, like getting an input of what the visionary thinks that's going to happen. And that's what we're all about, and that's what we love on the LP Roundtable. We want to get these insights from the visionaries before the world sees them. So thank you very much for your
Thank you,
time,
Rick.
and I'm looking forward to what's coming.
Yeah, it's been a pleasure. Thank you.
Thank you, and see you on the next one. Bye.
Bye.